Welcome. I was just checking out some volume today. I'm glad you came to Motivation Station, 3rd grade math edition. We're going to be learning all about reading and estimating volume. Let's go with a joke of the day. How do you make 7 an even number? You get rid of the S. All right, back to volume today. The targets we're going to work on today are going to be reading and estimating volume. When we're reading volume of a liquid in a container, there are several steps to follow. The first thing we need to do is determine the scale on the container. It usually starts at 0 and then this one goes up to 200, and the ml means milliliters. So now I have to figure out what each one of these lines means, because this liquid falls right in the middle of two numbers. So I see that it has a line, and then it has 50, and then a line, and then 100. So now I have to figure out that halfway between 50 and 0 would be 25. So each line goes in 25 milliliter increments. So the second step is to place the container on a flat surface. Then you would get eye level with the container so you can see exactly where it lies, the liquid lies. And then you find out that it goes from 50, 100, 150, and it lands in between 150 and 200. And we said that the scale was 25, each line was 25, so 150 plus 25 more would be 175 milliliters. So let's do it again with this container. We determine the scale, and the bottom is 0, and it goes 20, 40, 60, 80. So I can see that the numbers skip count by 20s, but then in between there's one line halfway, so I know that between 20 and 40 comes 30, and between 40 and 60 is 50. So this one, if I get down and look at it, lands right at 50 milliliters. So this container has 50 milliliters of liquid. Let's do more practice determining the scale. If we take a look at this graduated cylinder, we can see that it counts 10, 20, 30, 40. So I can see that it's counting by tens. And if I were to count how many lines or sections in between each set of 10, I could see that there are 10 lines. So from 30 to 40, it would be 31, 32, 33, 34, 35. So each one of those lines is worth 1, so it skip counts by ones. The next one looks the same, but the numbers have changed. It counts by hundreds, 100, 200, 300. So each line in between wouldn't be worth 1. To go from here to here in 10 lines, each one of those lines would be worth a 10. So this one skip counts by tens. This graduated cylinder looks completely different. It starts at 0, even though it's not written, and then says 50, 100, 150. And in between, from 50 to 100, it's 1, 2, 3, 4, 5 sections. So each one of those lines is worth 10 also. So the lines skip count by tens. In this last graduated cylinder, it looks like it goes 10, 20, 30, 40. So in between, there aren't 10 lines this time, though. Each one of these lines, let's see, 10, then there's 1, 2, 3, 4, 5 sections. So from 10 to 20, making 5 jumps, this one counts by 2s. So now let's practice reading volume. The first step is still to determine the scale. And if I look at this one, it starts at 0, 10, 20. So I can see the big numbers count by tens. And there are 10 lines in between 10 and 20. So I know that each one of those lines counts by ones. So then if I want to find the volume of the purple liquid, I know that it lands at 10, 11, 12, 13, 14, 15, 16. This one has 16 milliliters of liquid. This next graduated cylinder, we have to determine the scale. It counts by fives, And from 5 to 10, there is 1, 2, 3, 4, 5 lines. So I'm going to say that this one also counts by ones. Each one of those lines is worth 1. And it lands up here between 15 and 20, so I'm going to start at 15 and count. 16, 17, 18. This has 18 milliliters. This one, skip counts by 20s. 20, 40, 60, 80. And in between there are 10 lines, so they wouldn't each be worth 1. To get from 20 to 40 with 10 lines, they would be skip counting by 2s. So now I can find my volume at 80, 82, 84, 86 milliliters. Last one. Oh, this one's counting by 90, 110, 130. It's still counting by 20s. And then there are 10 lines in between from 110 to 130. So it's just like this one. Each one is worth 2. And so when I go to read my volume, I start at my 150, 152, 154, 156, 158, 160, maybe up to 162. Now we're going to change gears to estimating volume. When you're estimating how much volume a liquid has, you need to think about items that you already know about. For our purposes in 3rd grade in this lesson, we're going to use a 2-liter bottle because you all have seen a 2-liter bottle of soda, and that's going to be your benchmark for comparing volume. When we estimate volume, again, you're going to compare everything to a 2-liter bottle. So picture that 2-liter bottle in your head, or if you have one, go get it and hold it. The first thing we're going to look at is a gallon of milk. Now the sizes on the screen are not the same as they are in real life. So now you're going to have to picture a gallon of milk. Is it bigger or smaller than a 2-liter bottle? You guessed it. It's right. It's bigger than a 2-liter bottle. Now let's look at a juice box. Is a juice box bigger or smaller than that 2-liter bottle? That one's an easy one. It's definitely smaller. The next thing we're going to look at is a bottle of glue. Is that bigger or smaller than a 2-liter bottle? You're right, it's smaller. So we could say it has less volume than a 2-liter bottle of soda. A coffee cup full of coffee. Is that bigger or smaller than a 2-liter bottle? You're right, it's smaller. So the volume would be less than a 2-liter bottle. And finally, let's look at a bathtub. Think about your bathtub. Does it have more liquid when it's full than a 2-liter bottle or less liquid? You're right. It is bigger. It has more liquid than a 2-liter bottle. Let's review what we've learned about volume. When you're reading volume, your first step is determining the scale. Then you place your container on a flat surface, get eye level with the container, and then read at the middle of the container. Then when we're estimating volume, you think about items that you already know. For instance, use a 2-liter bottle as your benchmark for comparing. Now, how can you practice this when you're at home? Well, if you have a 2-liter bottle or know what one looks like, I'd like you to do a couple things. First, I'd like you to list 3 things that are bigger, that hold more liquid than a 2-liter bottle that we haven't already talked about. You can't list the bathtub or a gallon of milk. And then I'd also like you to list 3 things that are smaller, that hold a smaller amount of liquid volume than a 2-liter bottle. But again, you can't use the juice box or the glue bottle that we talked about. Have fun with it, and maybe you can make a list of more than 3 of each. That's all for today's lesson in volume. I hope you have fun practicing on your own. And I hope you also can see the connection between math and science with volume. I'm Miss Kay Johnson, and I'll see you next time.